Welcome back. So here we are. We're in lecture 7-3. Now in 7-3 we're going to deal with dictionaries. Now dictionaries, they're a lot like lists. And let's look at this real quick. And this is going to be a little Jupyter Notebooks. Talk about it for a second. So here's my Jupyter Notebooks, and you remember how to share it. You'll click share, and that's how you share your notebooks out. But over here on the left, I've got an outline of how everything's set up. And I can add cells, add text, or a coding cell or text cell. And how I'll double click this. The pound symbol, just one of them, is the highest level of organizational structure. But when I come down to scalars and vectors, I've got two, so that indents it in. And then the things that are in are two, and then what's in tuple, they go in three. So that's my levels of indentation, and I can collapse that whole thing up to where it just tucks up out of the way. So it helps me if I'm working on something, I don't need to wade down through everything. I can just go over there and collapse it and click on it and it goes away again. So we've dealt with scalars and vectors. We dealt with tuples and all those things in it. 25 cells in there between code cells and text cells. We had 80 cells in lists. Whoo, that was an hour-long video. I think that one before it was 45-50 minutes. Might have been a few more. Told you this is the longer one. Let's go deal with dictionaries. All right. So a dictionary is similar to a list, but the order, it doesn't matter. It doesn't matter because we're not dealing with an index like we did before. Like, well, wait a minute. If we're not dealing with indexes, what is it? All right. Now let's think about this. It's called a dictionary. What is a dictionary? What's it look like? Well, a dictionary is traditionally some book, or now it's a digital book, that lists words and their meanings. So there's a relationship between the word and whatever follows it. All right. Keep that context in mind. That word, we're going to call it a unique key, and the definition in a dictionary will equate to a value. So there's a key and a value. So we're going to create, using the curly braces, tuple, parentheses, list, square braces. Now here we are at the dictionary, and it's curly braces. So I created an empty dictionary. Yep, curly braces, there's nothing in it. Here I'm going to create a dictionary using the parentheses, the curly braces, and that's an assignment operator. So I declared a dictionary called Bierce, and I assign whatever's in the curly braces. Remember I showed you that colon. That colon is what separates the key from the value. Set up here. Key and value. Keys have to be unique. Have to be unique. I can't have two keys with the same thing in them. So I can't have two of them that say day. It's a unique identifier. It's conceptually something we see in databases quite often. So that key day is related to this value. The key positive is tied to this value. Misfortune, this value. So when I say print Bierce, it's going to give you the key value, comma, key value, comma, key value, wrap it all up with a closing curly brace. So with that said, what are the keys for this one? First, middle, last. What are the values? While, E, coyote. Print Acme customer. Okay. Now this next one, Acme customer equals, and I'm going to define this dictionary. First equals while, middle equals E, last equals coyote. Now wait a minute. I declared them up here using curly braces. It's not a traditional declaration. This is the dict function. The functions are passed values in parentheses. I passed it each individual combination of key and the words that were associated with it. So just like I had here, here's the key and the value. Here's the key and the value. Key and the value, key and the value. Print it out, there it is, the same way. So I can use either a traditional assignment operator, declare it, initialize it with the assignment operator, or I can do it without using the curly braces and it formally written. I can do it with the dict function. They both result in the same thing. Now, I want to convert something to a dictionary using the dict function. Well, what do I want to convert? Let's see. I've got, look at this and tell me what you see here. I have square braces in square braces. So I want to know, what data type is this? That's a list. And what's in it? Lists. Okay. I have a list of lists. Nested lists. This next one, I say, you know what? I want to take that list and I want to typecast it to be a dictionary. Boom, there it is. I typecasted it. Now, I didn't take that value and put it anywhere, so it's just temporary. What is the data type of LOL? It's still a list. I never changed it. Okay. So let's look at LOT. And it's a list to a tuple. A list, or list of tuples. So a list of tuples, how is that going to work? Well, go ahead and run it. The same thing. It's not necessarily, I'm taking a list of tuples and I'm converting it to a dictionary and printing it out. But I never really changed lot. I never changed that list. That list is still it. We'll do it again down here. That's LOT. If I run this, it's still a list. That was a temporary thing. If I wanted to, I could have stored it in a new variable of the data type dictionary and used it as a dictionary. Same thing here. We're going to take tuples in a list. Oh no, it's a list. It's a tuple of lists. Lists in the tuple. Now wait a minute. What's that tell us? Since it's a tuple, I can't change what's in it. But if I convert that tuple into a dictionary, and if I run it, I can see that, yep, it looks like a dictionary. If I stored that as a dictionary, I can change these things. If I stored that as a list, I can change these things. But while it's a tuple, they stay the same. Unless I overwrite it. All right. A list of 2-character strings. It breaks them apart. So we end up with a key and a value. Key, value, key, value. Same thing here. Key value. Now on this one, it was tuples. There's a tuple with 2-character strings in it. This is list with 2-character strings in it. So in this next section, we've got a dictionary. Key, value, key, value, key, value. So conceptually, we should be good here. We know there's a key and a value. Print it out. There it is. It's a dictionary. We see it in the curly braces. All right, let's take the key Jillian and put in there Jerry. All right, wait a minute. Key. Where's this coming from? This is different. So I've got a list. I've got a dictionary. And this dictionary, I don't have a Jerry in it. But what I did was I said, you know what, take Pythons. And here's going to be my key, here's going to be my value. Pythons is my dictionary. So take this dictionary, key, value. The key has a value of Jerry. And we saw that up above. It's a little ways now. Right here. Key, value. So we said take that dictionary and add to it, if you don't have Gilliam in there, add this on. So had there been a Gilliam, we would have overwritten it. There is no Gilliam, so it adds it, it appended it. Tacked it onto the end. Same thing, but instead of Jerry, now it's Terry. Wait, we have a Gilliam in there. So I'm not tacking it on the end. Unique identifier, it's a unique key. So now we're going to take Gilliam and we're going to overwrite it with whatever that value is. Okay. We can use that key to go find things. We have that SumPython's dictionary here. And this dictionary, let's go print off John. John is the key. Tell me what's in John. The value is Cleese. It's going to give us the value for the key. This one, we've dealt with the in back when we dealt with the for loops. So we're going to take the print function and we're going to pass it whatever comes from this. Groucho in SumPythons. Is there a Groucho in SumPythons? It's a test. This is a Boolean. I'm going to get a yes or no. Is there a Groucho in there? Nope. And it's looking for the key. print some pythons, well, that's that dictionary up there, get John. Is there a John? Yes. What's it going to print? The value. Get the key, it's saying get, passing get function, the key, and it returns the value associated with the key. Print some pythons get, I pass it Groucho, and not a python. Is Groucho there? No. Groucho's not there. And before, when we did this just about the same thing, is it in there, yes or no? We know it's not in there. We said, go get it. This is what happens if it's not there. This is what we return if that's not a true statement. Couldn't find anything. Well, here, I gave you this. Go get Groucho. If there was something in there for Groucho, it would have returned it. Since there wasn't, well, give them this. That's our default value. Let's do another one. Go get Groucho. There is no Groucho. Would it give us? None. Nothing. There is none. Tell me all the keys using the keys function. So we've got a dictionary. I don't necessarily know what's in it. The dictionary is called signals. Well, give me all the keys, and it will return me a list of all the keys. And there it is. There's our keys for that dictionary. And it returns the dictionary keys as a list. This next one, we run it, and it's typecasting. Signals.keys. Let's see. Is this thing going to run? There it goes. So I'm going to print the list, signals.keys. Give me that list in there. Just a list. I don't want it as dict keys. I want that list. So I took that, typecast it as a list, and now I have a list containing all of the keys that I'm dealing with an index 0, 1, 2. What's the data type of this object? It's a list. Well, give me all the values in this dictionary using the values function. Print list signals values. Give me all the values in signals and dump them into a list for me. That's what's happening. And there they are. Each of the values. The other one was the keys. This one's the values. Now, this is something that's, I consider it important. And it's important for a reason. Because a dictionary is a funny kind of structure to us up to this point. It's kind of funny. We're kind of used to strings. We're getting familiar with tuples and lists. We've got lists, and I can get in there and I can navigate through them using a for loop. I can't do that with this dictionary so well. But what if I went and I got the things out of the dictionary and I put them in two lists? The keys list and the values list. And these two lists are what we call parallel. The index for the first value is related to the index for the first value in the other one. So index 0 in this one is related to index 0 in the other one. Index 1, index 1. It's a relationship. We call them parallel. That's something that we may play with a little bit. So I can go get those values, put them in a list, just like I did with the keys. Let me get all the key value pairs with items. Go in there and get these things one by one and bring them back to me. And there they are. I want all the items. That gives me every key and the value. Key, value, key, value. How long is the dictionary? We'll use that len function. Combine two dictionaries. Now this one, they call it unicorn glitter, having these asterisks. It's new in Python. They started using it in Python 3.5. So if you're using 3.2, 3.4, or any previous ones, this doesn't exist. It's not built in yet. So essentially what we can do is I have a dictionary with a couple of combinations in it. Key is A, items agony, B is bliss. It said, you know what? I want to print out first and second. Now wait a minute. In a roundabout way, this is saying we're going to merge them together. But there's a catch. And the catch is a dictionary can only have unique keys in it. Well, first has a B and second has a B. Which B are we going to end up with? The last one we saw. Combine them together. Take this, and then when we tack that second one in there, it overwrote it. So essentially when it started working through this, it said, all right, let's get first, and it went got A, agony, B, blissed, and it says, all right, now get second. Second is B, bagels, up, overwrite that, and then C, candy. No duplicates on the keys. We're not limited to just what we did here. We can go through and we can have multiples, first, third, second, whatever order we want. And order matters. We know order matters. If I want to combine dictionaries, this is the way to do it. I'll do it with the update. And I'll use the update function, and I'll just pass it what I want to tack on the end. Now, keep in mind that same rule has to be unique items. You can't have duplicates. If I want to remove something from the dictionary, I'll use the key and delete. Marks is the key. I say delete the dictionary Python's key is marks, delete that entry. And it will remove it. It's gone. So before we had marks that we added in here, second from the end. It went in and it stripped it out. We don't have anything between Palin and Howard. Marks is gone. Okay. So I can go get the key and delete it with pop. Remember what pop does. Pop gets it. Alright? And if I don't do anything with it, it throws it away. I can do something with it if I wanted to. I can go get what's in there and store it somewhere when I pop it out. So just remember that. That functionality associated with pop. We talked about it before. And I can pop out more than one item. I'm not limited to just popping one. Pop them out by the key. I can delete whatever's in there using the clear function. And when I do it, that stuff's gone. And we can test to see if there is a key by using the in keyword. Now that's that test. Is there Chapman in Pythons? Returns a Boolean. Is there Palin in Pythons? Returns a Boolean. Test to see if something's there. And if it is true, then you can act upon that. We can overwrite what's in something by assigning a value. And we've dealt with this previously. Same concept. Signals blue, confuse everyone. If there is a signals blue, it overwrites it. If there's not a signals blue, it adds it on the end. Simple as that. Okay. If I want to copy this dictionary, I can use the copy function. It'll copy it over. Oh, here we got that confuse everyone. Take signals. Add confuse everyone to the end of it. What's in signals? There it is. What's in the original? There it is. Oh, wait a minute. I took a copy of it and stored a copy. They're not. That's not like I say original signals equals signals. That's different. This makes a copy and saves a duplicate in the new variable we declared. This does a lot of things that it kind of goes back to what I was talking about, the pointer and what's a pointer and what's not. And I shouldn't even use the word pointer. I use the word shortcut. Let's use the word shortcut. What is a shortcut? What's not a shortcut? So we have this signals, and we copied it over to signals copy. So they're identical. I added sweat to it. I put for red, I put sweat in there. And that's at index 1. So for red, index 0, index 1. I overwrote it. Now wait a minute. It overwrote it to both. It overwrote it to both. This is where it gets kind of funny. That's a pointer. It's a pointer. But they're going about this just trying to confuse us left, right, and sideways. So I had it. I changed it. And there we go. We're back again. It gets confusing. All right. Don't let this beat you up. We're not going to spend a lot of time copying these things or digging deep into these structures. Okay. Let's jump on down here. We're going to compare dictionaries using the comparison operator. We've got two comparison operators we'll commonly use for the dictionaries. Equivalent and not equivalent. So here we go. Equivalent and not equivalent. There is no greater than, equal to, less than. We don't have those in here. We've just got these two comparisons. We can use the for and the in loop to work our way right on through there. For value in accusation.values, conceptually this is something we've already done, but instead of just running through the list, we're running through the values in the dictionary. Let's go through each one and print the value. Go through each of the items in there. The items are the key and the value. Key and value. For card in accusation. For card in accusation. Accusation is the whole dictionary. But it only gets the key. It only gets the key. If I'm specific and I say the values, so if I'm implicit, it just gets the key. If I'm explicit, it'll go get the values. If I'm explicit, it'll get the key and the value. Card, comma, contents in accusation dot items. So I prefaced it. I put a card up front, and then room. Has the, so card, the card is what we have, card, and then we've got the contents. So card's the key, contents is what we're going to call the value. Key, value, card, key, and then we've got another string, literal constant, value. String literal constant, key, string literal constant, value. For each key, it's going to do it as we go through the iterations. Go to each one. Got a key? Do it. Next key, do it. Is there another key? Yep, do it. Is there another one? Nope, we're done. Okay. Now comprehensions are something, we have them in lists. I didn't talk about them so much up there, but they exist, and I didn't talk about them by name. Okay. And let me get this. And get rid of that. So here's comprehensions, and we'll start with the first one. We've got word equals letters. Well, that's a string. And count how many letters are in there. And that's going to be our dictionary is key value for letter in word. Print letter counts. Letter, value, letter, value, letter, value. So it steps right on through that string, one item after another. For each letter in word, go through and tell me how many times it's in there. Okay. This again is not something we're going to have to dig deep into. We'll go ahead, we'll wrap up here. Now this one's not quite as long as the previous one, so we'll take a little bit of a break here and go through and play with this. There's some more explanation in the text on it. I may add some more stuff in here between now and when I post this. Okay? So I'll come back and see you in sets.